In this video, we'll be going through the process of evaluating a logarithmic expression. So, for example A, I have log base 3 of 81. So what I want to know is what exponent would I need to put on 3 to get 81? So it may be useful to set this equal to some unknown value. So I'm going to call that x. So what I'd like to do is rewrite this as an exponential, because I know how to solve exponentials using like bases from the previous unit. So I've got 3, 81, and x. So remember, the base of my exponential is going to be 3, but the exponent is going to be x, and that's going to be equal to 81, because I want to know what exponent goes on 3 to give me 81. So looking at 81, I could write that as a power of 3, or I'd say 3 to the 4. And now we know that the only way this could be true would be if the exponents are equal, so x would equal 4. Meaning that log base 3 of 81 equals 4. The second example, I'm looking at a base of 2, and I want to know what exponent goes on 2 to get 16. So again, I set this equal to x. I can say 2 to the x equals 16. I know 16 as a base of 2. Power of 2 is 2 to the 4. So again, equating my exponents, x once again equals 4 here. If we move down to log base 4 of 64, I'm going to do the same thing again. Set that equal to x. I'm going to say 4 to the x equals 64. That's going to have a base of 4 as well, where I'd have 4 to the 3, because 4 times 4 is 16, and 16 times 4 is 64. Equating my exponents, I get x equals 3. And in the final example, I have log base 8 equals 1. So again, what exponent would I have to put on 8 to get 1 as an answer? So I can set that equal to x. I'm going to say 8 to the x equals 1. And without using like bases here, the only way we evaluate a base and get 1 would be if our exponent would be equal to 0.